Welcome to this video. This exercise is also an exercise of interacting with data providers, getting data in JSON format, and processing this data in Python. In this exercise, we will be working with the World Bank Open Data. So the World Bank Open Data provides access to different country level and demographics datasets about many countries over time. We have used this data before, and feel free to take a look at the documentation of the API it provides. What's important in this data is that it's organized by country or indicator. So we can access data by countries or by indicators, and the indicator is basically what kind of data we're looking at. And as you can see here, there are many indicators that the World Bank data provides. In this exercise, we're interested in different OECD countries. So those are developed nations, as well as the following two indicators: health expenditure as a percentage of the GDP, and life expectancy at birth. For both indicators, we're interested in this data in 2016. Now the general API endpoint is the following: api.worldbank.org/v2/country, then the country name, /indicator, then the indicator name. And then we can provide optional parameters such as the date, which is 2016 in our case, the format, which can be either JSON or XML, which is JSON in our case, as well as how many hits we want per page. So I set this to 300 to make sure we're getting most of the data in this request. Now to get data about these countries, we have two options. One option is to issue a request for each one of these countries. So if you take a look at this example here, in this request, I requested data about the USA, and I provided the indicator here, the indicator name, which corresponds to the health expenditure as a percentage of the GDP. The other option here, instead of providing a country name, I can say all, and this will basically give me the data for all of the countries. So this is a handy feature here, because instead of issuing 20 or about 20 individual requests, maybe 25 individual requests, we can issue one request per indicator, get all of the countries, and then filter these countries out. So what I'm going to do now, I'm going to issue a request for each one of these indicators and get all of the countries associated, all of the country data associated with this indicator, and then filter them out after the fact. So first, I'm going to create my endpoints. The endpoints are basically the following. I'm going to copy and paste this, and I'm going to make it a formatted string, because what I want to do here, I want to customize this to be indicator, which will be eventually read from the list indicators. As for country, I'm going to say all to get all of the data. That's a list comprehension. And in this list comprehension, I can, for each indicator in indicators. All right, so let's see what's inside this list. Oops. It's endpoints. We've got two endpoints for each one of the indicator. Next, what I'm going to do, I'm going to fetch the data. So that's very similar to what we've done so far. We can do it for each one of the endpoints. I'm going to do it in a list comprehension as well. I'm going to call the function get each endpoint for endpoints in endpoints. Now, knowing that this is JSON data, I'm going to do the conversion as well. So I'm going to get .json to get the JSON data read into Python for each endpoint in endpoints. It looks like I don't have the package request, so I have forgot to run this cell here to import requests. Let's rerun this cell again, and now it's fetching the data. So I've got two items in this list. Let's take a look at the first one. That is basically the data resulting from the request. Now the World Bank API provides the data in two pieces. The first item is basically a metadata saying how many pages in total were returned, how many items to 264, the source ID, and when this data was last updated. The data itself is the second item, which is this whole list of dictionaries. And each dictionary corresponds to this data, this indicator for one country, or one region actually. So what I'm going to do now, knowing the structure of the data, I'm going just to get the second item, because the first one is just metadata, which I don't care about. So I'm going to get the first item for the in data, and then overriding data again. So when I call data 0, that's basically the values of the indicator, the healthcare expenditure for all of the countries in 2016. The next step is to basically restrict this data to these countries, because this returns all of the data in the World Bank, including all countries and all regions. So you can see that the first value is the value associated with the Arab world, which is not one of these countries. So we can do this filtering step in either in Python or in Pandas. What I'm going to do first, I'm going to take the list of these countries and store them in a Python list. So this is a markdown in the Python notebook. I'm going to copy and paste it into a list called countries. Now if I copy and paste it in a list, I have to manually then delete the dashes, and then I have to manually add a quotation for each country name. This is definitely feasible given we have about maybe 25 of these names. The other alternative is, instead of doing this manually, to use Python itself to do it. So basically, I'm going to store countries as a string instead of a list. So this is a big multi-line string, hence the 3 quotes. And what I'm going to do here, I'm going to use regular expressions to extract country names. So I'm going to import regular expression package. And then my expression here is the following. I'm going to look for any alphanumeric character which will capture any alphanumeric character here. Now this may repeat, so I can do something like repeated here. So this is basically any alphanumeric character repeated. And then what I can do, I can call the function find all countries, and that will basically match the expression and find all matches here. Now at first sight it may look like it's working fine. It's only when you look into what you got you realize that there's something wrong. So for instance, the first 5 countries are fine, but Czech is incorrect because it's the Czech Republic. So what's going on in here is that it basically ignored the space because the space is not an alphanumeric character. So that's an issue. Then maybe we want to add the space. So what I'm going to do, I'm going to say, oh, okay, either alphanumeric or space in a group repeated. We'll do that, and this will actually capture the whole word, like a Czech Republic, New Zealand, for instance. It will end up with an extra space. So this is not a big deal. We can actually trim the space by calling the method strip on each one of the strings. Or instead, we can slightly modify our regular expression to be starting with an alphanumeric character, which is not a space, and then followed by alphanumeric or space repeated. That basically will give us the list of the countries from this whole string, which was a markdown text in the notebook. So I'm going to call this countries again. I don't need the string anymore, so these are the countries. The next step is to match countries from the data we have. Now, if you look at data, it contains multiple things. It contains information about the indicator, and it also contains information about the country, as well as the value and the date and so on and so forth. So what I'm going to do here, I'm going to simplify things. I'm going actually to load this data into a pandas data frame. So the health data will be loaded from data 0, because that was the first indicator. And I'm going to create a data frame from this list of dictionary. So pandas will understand a list of dictionary is a list of records. Each value will be a column, and each key from the dictionary will be a column name on the column axis, and the values themselves will be rows. So that's health. And we can see here that this data frame has multiple columns. What's important for me is basically the country name itself, as well as the value of the indicator. Now I can do this for health, and I can do this also for life expectancy. And obviously this is data 1, not data 2 here. Okay, so far so good. Now what we need to do next is to basically extract some information from these two data frames. We need to organize things a bit. And you can see here that the value of the country is basically a dictionary containing the ID of the country as well as the name of the country. I'm not interested in ID here because what I have are country names. So that's something important we need to do. We need to basically make it a bit more useful. So I'm going to do this for each one of these two data frames. I'm going to change the country. Let's take out the head here. It's just, oops, polluting the notebook. Let's take out the head. Looks like not responsive. So let's go ahead and take the country. And you can see that this is a series. Each element in the series is a dictionary. What I need to do, I basically need to extract this thing, which is the value associated with a key called value. So what I'm going to do, since each one is a dictionary, I'm going to apply my function. Each x will be one of these records, and I want to peek at x and get the value associated with the key value. That basically will give us the country names in health. Since I don't care much about the IDs, I'm going to override this in the country, in the country column in the health data frame. And I'm going to do the same for life expectancy. I'm going to override country in the life expectancy. Now, so far so good. I will do a few more data transformations before we go ahead and restrict these countries to be these countries. Now, ultimately, the question is asking us to rank these countries based on their health expenditure, as well as based on the life expectancy, and then answer the question what countries spend a lot on healthcare but lag in terms of life expectancy. So which one of these countries spend a lot on healthcare but they don't get the benefit of spending a lot on healthcare? So what I'm going to do then is to do the following. I'm going to do a few data transformation, and I'm going first to set the index to be the country in each one of these data frame. So health set index, well, health itself is a data frame. The index is still the default index ranging from 0 to length -1. I'm going to set the index to be country. And I'm doing this because then it will be very easy to combine the data with the life expectancy data, because Pandas is going to align the indices when I do any when I do data combination or data kind of addition operations. Okay, so that's that. You can see that the index is the country. Now what I care about here is value, right? Everything else I don't really care about. So I'm going actually to do extract this. Let's call this health series and take value as a column. So health series is basically this series. You can see that we've got some missing values here. Next step is to do the same on life expectancy. So I'm going to extract the life expectancy series from the life expectancy data frame, setting the index to be country and taking out value. So life series here is this series. All right. Next, we need to restrict this data to the countries that we care about here. Now those countries are eventually stored in this list countries. How do we get a subset of health series and life series in which the country is some of these countries? The answer ultimately depends on what country is in those series, and you can see that this country is on the index. So one way to do it, since this is the index, is to basically fancy index, right? So health series I can do something like this: USA, for instance, and Canada, and I get the result here. It's a fancy indexing, so no value associated with probably not the USA, it's the United States. Okay, United States and Canada, and you can see that we've got a subseries. So that's what we want to do. We want to put countries here. Simply speaking, instead of typing few countries, I'm going to put countries, and this will give me the slice. This is the fancy index. Don't forget, countries is a list. I'm going to call this one OECD Health to keep health series, and I'm going to call this one OECD Life, and I'm going to rely on the life expectancy series here to get that slice. Now we're very close to answer the question. Let's rank these countries based on their life on health expenditure as a percentage of GDP and on their life expectancy at birth. OECD Health, and then the function we need to call is sort values, because we are sorting across the values here. Now the sorting is ascending by default, which is not very useful because we want to do it's not clear, but probably what makes sense is to basically rank them in a descending order, because that's what we're interested in. Both options, I guess, are valid. We can either sort in descending, and in this case we can see that in terms of health expenditure, countries like the US, Switzerland, and France put a large percentage of their GDP towards health, versus countries like Turkey, Mexico, Luxembourg, they don't put a large percentage of the GDP. I'm going to do the same. I'm going to do OECD life expectancy, and I'm going to sort values again. So those are the life expectancies, and you can see that countries like Latvia and Lithuania have relatively lower life expectancies at birth, 74 years. If we scroll down, countries like Spain, Switzerland, Japan, they have large life expectancies. If the question was to get the country names rather than the countries themselves, we can then get the index, convert it to a list, or call the function keys. That will give us the index, right? And then convert it to a list. The question here is not very specific, so let's leave it as a series. Finally, let's answer the question of what countries spend a lot on healthcare, but they don't gain the benefit, they lag in terms of life expectancy. To answer the question, we need to combine the two indicators. We need to have high life, so we can do it in either way. Either we need to look for countries with high life expectancy and high expenditure, or vice versa, we can look for countries with low health expenditure and low life expectancy. Ultimately, we want to divide one of these indicators over the other. So let's go with the first route. I'm going to take life OECD life series, and dividing it over health series. Meaning countries that have a high value of that index, of this new index, will basically have a high life expectancy and low health expenditure series. Let's call this one health efficiency. Now notice that since the two series share the same index, pandas will do index alignment, so we don't have an issue at all, even if not all countries show in both lists, in both series. So let's take a look at health efficiency. Actually, you can see here that it's not a problem that the two series don't share the same index. Indeed, instead of dividing it over OECD health, I divided over health series. That's not a big deal because I can drop NA and see the non-NA. But to be consistent, I'm going to divide it over OECD health. We don't have any NA, so for those OECD countries, we have data for both life expectancy and health expenditure in 2016. So that's a new measurement, a new indicator. Let's call it health efficiency. A high health efficiency corresponds to high life expectancy but low health expenditure. And to take a look at countries that are doing well or maybe doing bad, let's do sort values. It seems that the United States is not doing well. It's the country that has relatively lower life expectancy but relatively higher health expenditure than all the other OECD countries. If we scroll down, we can see like countries like Turkey, Mexico, Luxembourg are doing much better. They spend a small percentage of their GDP, but still they have a higher life expectancy of their citizens. So this concludes this exercise. To answer such a question, we needed to go and collect data from the internet using the API. We need to clean and transform the data and do transformation and calculations in pandas.